Hello friends. Imagine you run a company, and an attacker sends a single web request, no password, no login, no hacking tools, just one crafted message to your server. And just like that, every customer name, email, phone number, and address is in their hands. That is exactly what happened between August 3rd and August 6th, 2026. A zero-day flaw, meaning a vulnerability that was unknown and unpatched, hit Metabase, a popular business intelligence platform. Two companies, Framework and Tally, confirmed that attackers reached their customer data through that single flaw. In this video, we are going to break down how that is even possible, starting with a technique called SQL injection, and building all the way up to why this one bug scored a perfect 10 out of 10 on the global severity scale. Alright, let's build up the core idea from scratch. Every web app that stores data talks to a database using a language called SQL, which stands for Structured Query Language. Think of SQL as a very precise set of instructions you send to a filing cabinet. Normally, your login email goes into the query as a value, a piece of data the database reads but does not act on. SQL injection breaks that rule. An attacker types something crafty into the input field, and because the app glues that input directly into the query string, it spills out of the value slot and becomes a new SQL command. Look at the left panel. The input is the word admin, a single quote, then OR1 equals 1. That single quote closes the value early, and the rest becomes live SQL that always evaluates to true. The right panel shows the fix, a parameterized query, where a question mark holds the slot, and the database engine treats whatever the user typed as pure data, never as code. Now here is where it gets interesting. Business intelligence platforms like Metabase are built to help companies explore their data visually, think charts, dashboards, and reports. To build queries safely, they use tools called ORMs, which stands for Object Relational Mappers, and Query Builders. These act like guardrails. By default, they wrap your inputs in parameterized queries, so injection is blocked. But here is the trap. Almost every ORM also offers a raw-SQL escape hatch, a method that lets developers write plain SQL directly. If a developer passes user-controlled input into that raw method without sanitizing it first, the guardrail is gone completely. And the riskiest spots are low-traffic flows that get less review, things like a password reset endpoint. That is exactly where the Metabase flaw lived. Next, let's walk through the exact attack chain step by step. Here is the attack chain step by step. The attacker needs no account at all. They send one HTTP post request, a standard web request that submits data, to the password reset endpoint. Hidden in that request is a crafted SQL payload. Because the endpoint passes user input into a raw SQL method without sanitizing it, that payload runs inside Metabase's database. It hands back a session token, basically a digital pass that says you are logged in as an administrator. Now the attacker is inside as an admin. They pull the stored credentials for every connected database and start stealing data. Framework confirmed names, email addresses, physical addresses, phone numbers, and login IPs were all taken. Tally confirmed email addresses and password hashes were stolen. One unauthenticated request. That was all it took. Next, let's decode why this earns a perfect CVSS score of 10.0. Now let's break down that score. CVSS, which stands for Common Vulnerability Scoring System, is the standard way to rate how serious a security flaw is. The version used here is 3.1. Think of it like a board of dials. Every dial at its worst position pushes the final score toward 10.0. For this flaw, the attack vector is network, so anyone on the internet can try it. Complexity is low, meaning no special setup is needed. Privileges required is none, no account required. User interaction is none, no victim has to click anything. Then come the three impact scores. Confidentiality, integrity, and availability, the three core pillars of security, all hit their maximum. That means full data theft, full data tampering, and full system disruption are all possible. That is every dial maxed out at once. Next, let's look at why a flaw in a buy platform causes so much more damage than a flaw in a typical app. Here's what makes a buy platform breach so uniquely dangerous. Metabase is not just one more app. It sits in the center of a company's entire data world. To do its job, it connects to every database a company runs, sales data, user data, analytics data, all of it. And to make those connections, it stores the login credentials for each one. Now think about what that means. An attacker who compromises Metabase does not just get Metabase's data. They get the keys to every database behind it. One injection flaw in the bilayer becomes a master key to the whole data estate. That is exactly what happened with Framework and Tally. A single attack on their shared buy tool opened doors to customer records across both companies. Coming up, let's walk through the defenses that can stop this kind of attack. So here are the 4 defenses that would have stopped this attack cold. First, use parameterized queries everywhere. Every query, including the raw-SQL methods inside your ORM, must treat user input as data, never as code. Second, harden unauthenticated endpoints. If a root like password reset does not need direct database access, do not give it any. Third, give each database account the least privilege it actually needs. A read-only analytics account cannot hand over admin credentials. Fourth, patch fast. CVSS critical scores, anything from 9.0 to 10.0, call for a fix within 7 days. The Metabase 0 day was patched, but the damage to Framework and Tally was already done. The big lesson is simple. SQL injection is completely preventable. What it demands is consistent discipline across every code path, without exception. Thanks for watching, and we will see you in the next one.